다음 강연을 위해서는 스웨덴에서 멀리 와주셨는데요. 스트로비는 교육 선진국으로 알려진 스웨덴에서 가장 주목받고 있는 코딩 교구이자 언플러그드 교구입니다. 가장 간단하고 저렴한 빨대를 활용을 해서 아이들의 상상력을 자극하고 또 이를 구체화하는 능력을 함양할 수 있는 교구로 잘 알려져 있습니다. 스트로비의 공동 창립자이자 토이 메이커인 에릭 톨스텐슨 씨를 무대로 모시겠습니다. 따뜻한 박수로 맞아주십시오.
Do you hear me now? Yeah. I was thinking there's very low speaker volume, or perfect for me on stage. But hi again. I'm Erik Thorstensson, all the way from Sweden. And today I'm going to talk about something called Invention Literacy. And just like the previous speaker, it's about the joy of inventing and making and understanding the things around us. A core principle in the future. So invention literacy, has anybody heard that term before? No? It's because it's a friend of mine who invented the term. But that friend is pretty well known in the maker community. His name is Jay Silver, and he is the inventor of the Makey Makey, amongst other things. But the term invention literacy is defined by him like this. It's the ability to read and write everyday objects around us. So like understanding how the lamp here works, how a ladder works, how a small robot or how the night light at home works. So to actually see the process behind the objects. And this is one of the really most inspiring areas to work in today. And what we do is make room for this invention literacy. So I'll start by talking a little bit about my own invention that it turns out is pretty good for learning invention literacy. And it is the Strawbee. You see the logo here. It is a thing that I invented. And I have my secret pocket here. Ta-da! Here it is. Very underwhelming, very small. Yeah? This thing, oh, hi, can connect drinking straws. Like this. So what is this? This is the first part of becoming creative and learning invention literacy, is observing an object, imagining what it could be. It doesn't have to be anything advanced in the beginning. It's just about your mind. So this is what we usually tell the students the first time. What is this? What could it be? And we have had 2 workshops here in Seoul the past days. So it's been a wand, like magic, Harry Potter, things like that. It has also been a bubble blowing device. It's been a lot of strange things. And then we do the second step. It's like I'm almost like a magician today. Same thing, the Strawbee connects to a drinking straw. Ta-da! What do we have now? Anybody wants to guess? This is how we did with the students at the workshops. We asked them, what is it now? And once we established the first step, that it's just about what you can, like, it's just your mind. Now when I did this, maybe it's antenna. Hello, I am from outer space. Or I'm a grasshopper. It can be all kinds of things. Or drumsticks. Imagination. But this little connector also made room for snapping these things together. And now we have a mechanical drinking straw. So it turns out that this little thing that I accidentally invented is really good for sketching objects in 3 dimensions to start to understand how the things around us work. So this is the Strawbees invention. And we believe to spread the invention literacy, on the slide there, is to actually start building, changing, doing strange little inventions yourself to actually start understanding how the objects work. So just like when you learn how to walk, you start walking really, really bad. You're like, this is the step 2 walking. Second step is like crawling around. And with inventions, it's about doing this, the first failures, really fast. Just starting to build and observe things. So we love, when you start building, it should start with something ridiculous. Like humor is one of the greatest unlocking devices for learning invention literacy. To be creative, you have to have a little bit of fun. Let's see if I went to the second step. So this is an invention that a kid did. The high five machine. It's a very simple little strange invention. It's a mechanism that they used. Another strange invention that comes out of just having a little bit of fun is, for example, this space helmet. So I will put this on now, just to show you what this is about. So. It's a soundproof helmet. It's a soundproof helmet that stops air from coming out in space, for example, and it also stops sound from coming out of the... But this is just about being a little bit ridiculous and fueling your imagination. So, have fun, be a little bit ridiculous at step 1. If we continue, we want to go on with our ridiculousness. That's the first unlocking device to get a little bit more confident in making something, because if I make something, at least it's fun. The second step is just like the previous speakers were talking about, the power of observation. So these tools, like this is our toolbox for actually learning invention literacy. To have a little bit of fun, like being slightly ridiculous first, observe. And it turns out that our system is really good for observing everyday technology. And to learn how something works, one of the best ways is to actually build it. So, for example, here is a tower, which is a truss structure. So this is mathematics, science, technology. This is space technology that they can build with regular drinking straws. And when you build it with a weak material, your brain can process what's actually happening in this structure. So when I put a high load on it, you can see that it starts stretching. You're cracking through failure. You see, when we put load on something to learn, the objects actually have to fail. That's when we actually learn something. That's when we see, if you build a bridge that works, this is a pretty good beam. And now you saw our failure. We have a failure there. So then we go, first we fix it and see how we can support it. But now we realize that there's a lot of pull forces when I start swinging it over like this. So for me, being a mechanical engineer, this is really, really fun to show that as a child you can build something that is 3-4 meters without any problem. Another thing to understand an everyday object, a classic object that we usually use to teach the power of observation is this classic little object. There's going to be a lot of things on stage today. I figured it's fun to do a little bit of show and tell together. So does anybody see what this is? I imagine somebody saying umbrella. Is that correct? That's the fun thing. We don't have the interpretation backwards here, so I'll just have to read and figure it out. So you create the mechanism behind an umbrella. To understand it, the first time you need to have your hands on and make these simple mechanisms. So here we have an umbrella, and in this workshop for the students, we make room for them to observe it, take the time to fail over and over again in the construction of it, because time is most important. So you actually have the time to sit there, try to make an umbrella that doesn't quite work the way you wanted it to. And maybe if a student, because we also introduced this magical tool for invention literacy, the scissor. But once again, invention literacy is not about the tools, it's about the mindset. But this is a really good tool. It's not very expensive, commonly available. So imagine that somebody cut this wrong, because this umbrella that I just showed was very symmetrical. So I cut this wrong. And then we end up here. So we still have this very good folding capability. Oh, pulling it apart also. So what do we do when we break something? We fix it. One of the mantras of Strawbees. So now when I open it up, it still works pretty well, like an umbrella, but what's happening there? It's going more upwards. There's something happening here. This is a failure. This is not how an umbrella should be. Or is it? This is where we can use our power of observation and association and imagination to turn this failure into a success. Failure is one of the best ways of actually learning or coming up with an invention. So in this case, if we start imagining what we're doing, we're out in the rain. So shh, sound like rain. Shh. Yes, there's rain. And then very windy, so we're walking with our umbrella like this. And when we push it, we can open up forwards so we can look and then fold it down when we need to. So this failure or this cut that was not as exact as we wanted it to be is the key to an invention. So when we teach them that to both have fun, use a little bit of ridiculousness, taking away some of the pressure, to use the power of observation and imagination to look at when you do something that doesn't quite work the way you wanted it to take that as an opportunity to learn something new, failure isn't as stigmatizing and scary. Actually, failure can be pretty fun. So sometimes the really creatively literate students, they fail on purpose. They're like, I'm just going to make this like this for now. And then it's one of the best experiences when you see that in the classroom. So, typical failure. But I would like to show the second generation failure. So we also, as you saw with the little helmet, we introduced coding and to be creative and observing in code. We have a little tool that is called the QuirkBot. It's a tiny, tiny thing. Now we have the camera again. Oh, there. Very small circuit board. So I put it in the top of the umbrella. I connect my motor. So this is also what we realized is that for the children to actually gain this experience and gain this confidence of building and constructing, it needs to be fast the first time. So they need to be able to go through a couple of iterations and just trial and error their way to a pretty advanced mechanical construction. So this is an automatic umbrella. We want it to fold up when it's raining. So when it's dark, we want it to fold up. So let's turn it on and see what happens. So actually, it's very bright here now, I think. Yeah, it's very bright. So it works the other way around. So something is wrong, once again. Or is it? If this opens up when it's sunny, it's only the name we need to change to make it a success. So the name umbrella that's automatically up when it's darker skies is a parasol that opens up when it's sunny. So just by changing, if we programmed it wrong in this case, we just change the name and then we succeeded. And then we can change the code if we want to. So that's what we want to teach. That's one of the experiences we really want to build, is the experience of failure as an asset. And also your observation can change the failure to something that is correct, or more correct. There's never one perfect answer there. So I'll turn that off a little bit. So, all these things, you might have heard me mention it, and I think it was part of the first talk also, build creative confidence. And creative confidence is that feeling where you actually start relaxing in your creative process, and you dare to invest the time that it takes to actually build something that is complex, or to solve a problem that is complex. So for us, to build this creative confidence, we have all these exercises, like the umbrella, and showing that failure isn't that bad, and we can laugh at it together, and then take it forward. So actually the empathy part is very important too. So just going to see here, the thing is, to get this creative confidence, by just having built maybe some of these weird robots that just move, I made something unique, or just by making it wrong, it turned into an invention. You dare going into a little bit longer, learning, for example, mathematics that can be tricky for a lot of people. That can be an area where you can go in, get the patients, sit down, and make the thing. So, creative confidence is key. And then you have this process that we use, where we introduce all those three pieces, lay the bed for this process of designing. And you can recognize it from the design thinking area that we were talking about before. So in design thinking, you have part of these things. We try to reduce it a little bit more, but also talk about the process of thinking as something that you can practice. And actually talking about thinking. And when you talk to the students about that, thinking is something that you can become much better at by practicing it. It actually remakes and remodels your brain when you're thinking in a certain way. So we introduced the So first we have the observe. The observe when we build something, so which we showed before. And then we cracked it and like, this is obviously a strange area. How do I fix this? Maybe two straws. They start ideating, and then they make remix. So for example, adding, we can do that now. I like just, was not planned, but for example, the place where we cracked it, the Strawbees is made, like I designed it because I'm a designer and I needed something to prototype with and to understand the problems I'm facing. So you can always add, change your structure, even at the last minute. So when students have invested a lot of time in the project, it's never like all failed. You can always change it. Instead of having glued a bridge with a glue gun and maybe spaghettis and just adding more and more things, you can refine it at the end and you can fix it. So that's one of our keys. And the observe, make, remix thing is something we introduce both in code and in the construction. So let's go over to oh, I forgot one of the ridiculous people here. Let's see here. Let's see which one we start with. We start with this one. And that one. Yes, perfect. So here are two examples of classroom experiences where we have a really fast observe, remix loop. This is built of drinking straws and trash bag. And you may recognize the shape. It looks very much like a kite, but it's actually a glider. So when I design classroom experiences, I want there to be room for a lot of random. I want there to be room for a lot of changing and testing. So in this case, I will start out with a plane that will most likely not fly well. Because once again, failure is one of the opportunities to understand what works and doesn't. So let's let it go. You see, it's stalling. It's not a perfect flight. Then we go in, we observe, we think. What happened here? It looked tail heavy, that's one thing. Maybe there was something controlling it, like the rudders on an airplane. So when we do teacher guides, we introduce the vocabulary they can use when you're thinking around this. So what I would do in this case, there's always many different ways of solving this weird flight pattern. One way is shifting the balance. So once again, we use this very lightweight material, high-tech. Birds' wings are very similar to a drinking straw material. Drinking straw, and balance it. And now let's test flying it the other way. Oh, much faster. So now we're on the other now we're on the other end of the envelope. So I need to do one small change. So I observe once again, it was really fast, wasn't it? Really fast, little bit too, you wouldn't want to fly in that one. So we changed it again, but we saw that the difference between our first throw, where it went like this, and our second throw when it went fast, so somewhere in between, there must be a solution. So actually what we're teaching in this is problem solving. Real problem solving skills, a problem analysis, but just through intuition and observing it. So I'll change it a little bit. This is dangerous, we'll see. Maybe we can get to a perfect flying airplane. One change. And once again, it's relaxing in the opportunity that we might fail again, or like slightly fail, but because we've already in this room established that there's a reason, there's an opportunity for us all to learn, it's not that dangerous. So let's see if we can get this. Okay, last attempt. Hopefully it's going to fly really nicely. Ah! Thank you very much. Typical example of an observe, remake thing. I think I'm the messiest person on this stage. Messiness is pretty close to creativity and also invention literacy. But we can control that. So some students are a little bit messy, some students are structured, and then you put them in a group together, and they will make even better things. So that's the thing, to actually find where you can use your skill. By just being you add to the group. I'm just going to show this one also, a fast little, this is a single leg walking robot. So first, let's imagine I put it on a little bit wrong. Really bad walker. We change, we observe, okay, the foot is not hitting the ground. That's probably why it's not walking. Then we move it all the way back, put it down. Oh, it's actually walking. I thought it was going to fall over there, but so it's all about this changing. So now it works. So we can let him be like that. Another thing that I could do would be to change the code. And when we teach code, we want it to be just as simple as it was when I cut the straw. We want the process to be more about their thinking than learning the coding language. So our language, this robot, is programmed like this. Let's see if we can zoom in on this little picture. Can you see this one? Oh, it's very small. Oh, there we drop down. There's basically just little blocks. So if I want to control a motor, I can use, for example, a wave shape, sine wave, pull it in, and then connect it to a motor, connect them, now it's very close to my face here, like that, and that's a finished program. So this is just a timing thing, so we want it to move back and forth, incredibly simple program. And that's how we want it to be. We want to be the entry level more about the thinking process than actually learning code. But at the same time, you're actually understanding how to control a microcontroller, how to make something blink, or like Erik's hat here. So my colleague Erik, he promised to demo his little hat. So he has a touch interface for his hat. So when he touches it, the propeller spins. And he thinks better, which makes us a much better company. So thinking hat, oh, now it's not there, now it's going, yeah. So just like I showed this, it's very simple. In that case, we use, I'll make a new code here, create new code, no internet, so we skip that. But it's a very simple process, once again, because we wanted to focus on their thinking. So now we have that loop, our two loops. We've done a lot of things. This is actually the core of design thinking. And I love that you introduced the previous speakers talking about design thinking too, because this is a different way. This is what we've been describing, can all be encapsulated under the term of design thinking, which is more about the process of like this observation, also using empathy to understand how something else works, or how somebody else might experience something. And it's also, as we said before, working together, combining two different skill sets to make something become a much better project. And then, like I showed you, to fail effectively. Instead of failing isn't bad, but failing and just giving up, that's the problem, because that's the way we get used to doing things. So we need to have opportunities to change ourselves, to change our thought process when we fail. Then we fail effectively and we get valuable knowledge. So I wanted to show an empathy project, because when you talk to the children about empathy, it's like a tricky subject to take up. This is one of our empathy projects. This is the Afraid of the Dark Pig. It's a kid invention. And let's see if it's dark enough anywhere on the stage here to make him actually afraid. But so this has a light sensor here. There's a light sensor. It's just, you can use any analog sensors. And when the kids put the program, when it's dark, it should move fast. And when it's light, it should breathe like I breathe. So now it's a 3-4 second sine wave, so it looks a bit calm. So you see it's moving a little bit? It's simulating breath. So the children, they made observations on themselves. How long does my breath take when I'm calm? So they're actually doing scientific exploration and investigation on themselves. And when I'm stressed, what happens then? So let's see if we can find a dark space somewhere here on the stage. This is going to be tricky for the camera. Maybe it's dark enough in here. No, it liked the blue light. Let's see if it's dark enough here. No. There's so much brightness here, so he's very calm. But I can show the basic principle. So I usually put this pig in a darker space, and kids can relate to this. A lot of the kids are afraid of the dark. Grown-ups too. So when I cover this, it starts shaking. See? Oh, actually, let's see if it's dark enough now. No, it's still not dark enough. You see? It's scared. Sometimes demos on stage, it's okay, you understand the principle. And it's so much fun to see these little objects. And once again, one group of kids, they made the program wrong. So this program, it was the Afraid of the Dark Pig. It's really, really cute. And now it's actually calm on stage, which is perfect. But then we have the freezing polar bear. So now we can actually light up again. This is a failed attempt at the Afraid of the Dark Pig. So this is another empathy robot. And some people say it doesn't look like a polar bear. But that's just in the imagination. It's white, it has a black nose, and it has little ears. It's very similar to a polar bear. And once again, we used the tool humor to come up with another idea when they failed, to make it, when the program was wrong. It actually gave them the idea. So now, you see it's freezing when it's light out. Does anybody have a scarf or something? Anybody have something that is a light little piece of clothing? No, like a... That one is perfect. Can I borrow it? I love using audience participations. Now, thank you. So you see it's freezing here, so we need to cover it. And there. Now it's calm. So we can actually introduce the term empathy and design thinking and talk about it. And actually by externalizing the feelings in these obviously non-feeling robots, people still experience, the kids still experience this, and we can discuss it. Thank you very much for letting me borrow. So let's take it off there. And I will, for all of your sakes, turn him off. He's not dead, but I'll turn him off because people really feel bad when it's standing there freezing all the time. And that's because we know that this doesn't feel, but we empathize with the object because it sends signals to us that we recognize. So it's very, very meta. Thank you very much. An applaud for letting us borrow this. Thank you very much. So, let's see what we're on time. It's pretty good with time. Wonderful. So let's see another little thing. In problem solving and exploration. Oh, no. This is not now. My favorite thing, actually, I get so happy because it's so much fun to see that we're actually understanding all this, that this is the perfect forum for these thoughts. So I want to show another experiment that we do and how we design our classroom experiences. So for this entire thing, in the design thinking loop with empathy, we design classroom experiences to teach us the value of just being you adds to the system. So some of you might, during another talk, have seen me using a pen and some cardboard and my foot. So what I do is I design an experience for the children, for the students, to make something that we can watch, all of us together. And just by having a different kind of shoe, a different shoe size, the project becomes different for each student in the classroom. So we actually control the variation. So now I'm just drawing the outline of my foot. And cardboard is another one of our favorite materials. So you see outline of my foot. So when the students do this, every foot looks a bit different. Maybe the shoe looks different. There's lots of reasons for variation. And that also makes room for example, if somebody doesn't have the agility to cut with scissors as good as the best students, for example, we still get information from the project. So has anybody cut cardboard in front of you on stage before? First time? It's good, yeah? So I'm cutting this. And this exercise I did the first time at a science festival in Gothenburg, where we're talking about physics. And one thing that we know from teachers is also when you get passionate about something, that also immediately just jumps into the brains of the students. They can see that you're curious. You're curious what's going to happen in this classroom, and then they get that feeling too. Because we don't do as we're told, we do as we see that the teachers do. So when you actually create the processes knowing that this is how our brain works, we get one up, and it's much easier to make an just so I didn't have to cut 3 on stage, I pre-cut some here before. Whoop. So you have to cut 3 soles, 3 feet out. And then we use a pencil to make the holes, like this. Make a hole. And this is the Strawbee in cardboard mode. See it there? So then it locks into the cardboard. I'm trying to, this is really tricky for the brain, to try to control, look at the camera, like the video feed and control it. So also thinking out loud as a teacher, like I'm doing now, to think about my process of thinking is also a very powerful tool. But then you as a teacher need creative confidence and also confidence in your ability to analyze. So let's go here. We connect our 3 foot blades. And what do we have now? Looks like a propeller. What it actually is a very interesting physics experiment called the Shumerang. So in the school when we do this, they all look different. And now, as we've already established, we're confident that it's okay to fail. We can fix it. So should we try this shumerang? Bit scared? So before I try it, we bend it into more of a profile like a propeller. Fold these toes up. Fold the back trailing edge down. So when we do projects like this, we can actually talk about aerodynamics, which is one of the most advanced fields of science and the things we know least about, because it's really tricky with the very turbulent fluid dynamics. So, as everybody, as my colleague knows, this is much heavier cardboard than we usually use. Yeah. So, this is it. I'm just tweaking it. Okay, are you ready? Let's test it. Hey! Very low cost material, and now because I know how this process works, I don't have to show the trial and error because it might be really tricky in this room if I throw this all across. So what I did now was generate lift. So a boomerang works by lifting upwards. And when I throw it like this, it goes like a circle through the room. So that's how a boomerang works. So they can try it just throwing it like this, and then it's going to go up. Usually I do that, but I don't want to make too much of a mess. It's already a little bit strange here. Typical example of what we do. So let's see. Whoa, did I miss the slide there? No, okay. One of our slides is popped out here. This is what we're about also. We love recycling. So we have a system where we can make all these things ourselves. You can make the connectors. You can make the cardboard pieces, obviously, with a pair of scissors. And connect them with the Strawbees. So right now, there was a slide with a little recycling machine, but I will do a description manually. So you turn it over like the crank. Something goes through a machine, and out comes the pieces. In this case, you can die cut these from any kind of plastic waste material. Because sustainability is not only in producing the future minds that we need, like we're doing, it's also learning how we use the resources we have. So as you might have seen, the straws are usually seen as somewhat of a problem. Because, you know, we have straws in the ocean. There's straws, there's plastic that's spread around. But it's not about the material, it's how we use the material and how we value materials. So if we want to do something that's really sustainable and future-proof, that's what we need to do. Show the value of a material that might feel like it's worth nothing, like the cardboard or the straws. So then we introduce that. And all of these things that I've been talking about today are things that we introduced in our new learning platform. So on strawbees.com, you can come in and download instructions of holding one of these classes. And the design thoughts, the thoughts aren't about our tool. Our tool is one way of actually increasing the speed of going through these loops, like the observe, make loop. That's what the Strawbees are designed for, to do this really fast and have fun. But you can apply that on anything. And just like the previous speaker, you were talking about just finding recycled materials, cutting things off circuit boards, using that. That is one of the biggest skills that we can teach, to actually observe, find the materials ourselves. And maybe then we can actually generate a lot of new makers and creators around the world, so they can take part of changing the world, and changing the world for the better. So that's our goal, and thank you for taking the time to listening to me. That is, or do we can do one final experiment. I almost stopped there, because I think I have like 2 minutes left. One last experiment? Yes. 5, yeah, so we have, then I would like to have 5 brave people coming up on stage. Anybody wants to come? Yes? 1, 2, 3, come, all of you. 2 more from this side. Oh, you too? Yes, come again. Yes? Welcome up. Oh, is there a way up on stage? Do you have to climb? Oh, perfect. So, exciting. Moving this way, you can stand in a little row here. I love sharing. Yeah, you can come. So we're going to do. Now you can stand. You're going to hold hands. Erik, you can actually also come up. Put your helmet on. Safety mode. Fly up on stage. So we're both Eriks. In Sweden, it's pretty common. So Erik, you can hold the crane. It's a crane operator. Hold like that, and then you come here. So you hold this. Hold the metal. Yeah. And then you hold hands here. That's coming later. So we close it, and then we can start looping up. So do you all see us? You see? So let's see if it's on. We turn the crane on. So this is how we talk about circuits. So we made, you might have, how many of you have seen the Makey Makey, for example? The banana piano. Yeah? This is a version where you recreate it, but now we make a banana crane. But in this case, if you hold my hands, oh, actually, we do this. Now you touch my hand. So by closing the circuit, you can, so we can just touch this. So the current is going through all of us, a tiny, tiny bit of electricity, and the little robot senses it. So that's examples of having fun with interesting things. Yeah, thank you very much. Thank you for coming up and showing that you can just invent. This is completely nonsensical, but it's really fun. And then all of a sudden we realized, for example, we can make something. What we did was close the circuit. But imagine that this here is a sensitive equipment in, for example, a boat. And that needs to be in the bottom of the boat. So if we have this circuit closing mechanism there, when water comes in, for example, it lifts the sensitive equipment up. So just by shifting, once again, the power of invention comes from the imagination, and also believing that I can just come up with a ridiculous idea like this and then actually apply it somewhere. So once again, thank you very much for listening. And yes, feel free to run into strawbees.com and find more of what we do. Thank you very much. Ooh.
네, 효과적으로 실패하라라는 메시지가 참 인상적인 강연이었습니다. 스트로비 공동 창립자 에릭 톨스텐슨 씨였습니다. 감사합니다.